and how a barycenter works. While Jupiter has the greatest mass of any planet in the solar system, it's not the densest. It is the most massive because it is the largest. If Neptune was the same size as Jupiter, it would be the most massive. And if Jupiter was the same size as Earth, Earth would be over 4 times more massive. As it is though, the diameter of Jupiter is 11 times that of Earth, and its total mass is 318 times more than Earth's. As we know, mass affects gravity. This means that Jupiter has a huge gravity, over twice that of Earth at 2.528 g at its surface. The gravity of Jupiter is so influential in the solar system that it affects every planet to one degree or another. Its gravity is strong enough to tear asteroids apart and capture 67 moons at least. Some scientists think that Jupiter destroyed many celestial objects in the ancient past, as well as preventing other planets from forming. One example of this, in particular, is 4 Vesta. Scientists even predict the gravity of Jupiter is so significant around the solar system that it is perturbing Mercury's already eccentric orbit enough that in a few billion years, the tiny planet may either crash into the Sun or be ejected from the solar system altogether. At the moment though, it could be the hero of the 4 inner planets. Without Jupiter acting as a cosmic vacuum cleaner, it wouldn't be sucking up dangerous objects like long-period comets, or perturbing their orbits enough to give them a little kick of energy so that they leave the solar system altogether. Jupiter is the 5th planet from the Sun, and it's 5 times further away from the Sun than Earth. Even so, it can be the 3rd brightest object in the night sky, after the Moon and Venus. I just want to show you how bright that is. Just using a handycam, we can see Jupiter quite easily in the night sky. With a maximum magnitude of -2.94, it can actually cast shadows. As a result of it being so obvious in the sky, it makes a very nice target for amateur astronomers. As consumer telescopes have improved in recent years, it's amazing what details you can see from your back garden. And what makes these famous patterns? The cloud layer is only about 50 kilometers thick and contains ammonia crystals, much like on Saturn, but the coloration comes from compounds heating up from deep within Jupiter and then rising. These compounds are known as chromophores, and when they reach the clouds, they interact with the UV light of the Sun to create these spectacular multicolored bands. This is quite the cycle though, and the face of Jupiter can change dramatically over time. Even if their colors do change, the actual latitude of these bands remains consistent enough to be given identifying designations, but they can vary in width over the course of time. Lots of storms and turbulence occur where these bands meet, and it is the reason and engine behind Jupiter's very famous Great Red Spot. This storm is huge. It can easily fit the diameter of Earth within it. It has existed for as long as we've known, since it was first discovered in the 17th century. It might very well be a permanent feature of the planet, but interestingly, it has decreased in size since observations began. The reason for its reddish color is unknown, and the color of the spot can vary greatly, from brick red to almost white. The most recent theory for its color is chemical compounds being broken up by the UV light from the Sun, much in the same way as the process that happens on the rest of the planet. The storm is actually much higher up in the atmosphere than the surrounding clouds, and as a result can interact with the sunlight a lot more. This would explain why its color can be much stronger than anything else around it. But Jupiter doesn't just have one scientifically interesting storm. Another storm, known as Red Spot Jr., formed when 3 storms merged into one between the years of 1998 and 2000, and it has so far passed unscathed by its bigger neighbor and is now quite a prominent feature of the planet. it could last for another couple of hundred years if it avoids the same fate of a similar storm which passed right through the heart of the Great Red Spot. So, what do we think Jupiter is made of? Well, much like Saturn, under the atmosphere are gaseous, then liquid, and then metallic forms of hydrogen. The further into the planet you go, the greater the pressure becomes. Under immense pressure, hydrogen acts as a metal, and beneath that is an ice or a rocky core. Because we can't recreate on Earth the immense pressures Jupiter experiences, we don't really know what properties these materials have at the core. Roughly 90% of Jupiter is thought to be hydrogen, 10% helium, and then trace amounts of methane, ammonia, and others. Jupiter rotates very fast, faster than any other planet, completing a rotation in only 10 hours. But due to it not being solid, it doesn't rotate the same speed all over, a rotation at the poles taking 5 minutes longer than at the equator. As a child, I was very curious why Jupiter wasn't a star. Considering Jupiter is so massive, plus it is predominantly made of flammable hydrogen, surely someone just needs to throw a match in to set it alight. Well, the sad news for my inner child is that stars don't really work that way. Plus, there's barely any oxygen on Jupiter to allow for combustion. Stars produce their heat from nuclear fusion caused by the extreme pressures found at the star's core. Current thinking is that Jupiter would need to be roughly 75 times more massive than it is now to be massive enough to be a star. Although, interestingly, its volume isn't too far off from the smallest known red dwarf. And yes, you may have noticed in this picture, Jupiter does indeed have rings. Nothing on the scale of Saturn, but there are 4 planetary rings. The main ring is very thin, but very bright. The rest quite wide, but exceptionally faint. The main ring is about 6,000 kilometers wide, and the only distinctive feature you will see is what is known as the Metis notch. Something else to note about Jupiter is its remarkably strong magnetosphere. It is 14 times stronger than Earth's due to the planet's liquid metallic hydrogen center. This makes it the strongest magnetosphere of any planet in the solar system, and is only beaten by the Sun's sunspots. There are a couple of reasons why this is really interesting. The first is that magnetospheres channel solar wind to the planet's pole, which produces magnificent aurora. The second is that the 4 biggest moons of Jupiter are protected from this solar wind because they orbit within the magnetosphere. This implies they don't need their own strong magnetospheres because Jupiter is doing that for them. However, this doesn't mean they are safe from radiation. Jupiter has a powerful radiation band around it, the same radiation band that has crippled any probe that went through it. The closest large moon to Jupiter, Io, passes right through the heart of this radiation band, receiving 3,600 rem per day on the surface. For a point of comparison, anyone exposed to this much radiation would be dead within 4 hours. Not the best home away from home then. When it comes to the Jovian moons, I'll only very quickly talk about them because I have made a separate video about them here. Jupiter has 67 known natural satellites. 51 are under 10 kilometers in diameter, but the largest, the Galilean moons, are some of the biggest in the solar system. They are Io, Europa, Ganymede, and Callisto, and they are all interesting in their own right. Ganymede is actually the biggest moon in the solar system and has a greater diameter than that of Mercury. And with this final thought, take a look at Jupiter through the infrared. Demonstrating the immense size and power of this planet, this dot at the bottom of the planet is the impact of an object from space, which, if it had hit Earth, could have spelled the end of our planet as we know it. We can be glad Jupiter is there, not only for its beauty, but because in so many ways it is an asset to our solar system. Thank you so much for watching this far. Did you learn something today about Jupiter you never knew before? And what planet remaster would you like to see next on this channel for this series? Let me know in the comments below, and I'll see you next time.
Thanks for watching. For this video, I particularly want to thank George, Brian, and John for their incredible support. Making this video required some long-term planning and work, which we were only able to do thanks to the consistency and sustainability of your memberships as Astronauts on Patreon. A huge thank you to everyone who has signed up. And if you'd like us to make more videos like this, you can join with the link down below. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Once again, a huge thank you from myself and the whole Astrum team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.